All right, here's a pretty cool one. So this one's to do with the factor of safety, which is the ultimate over the allowable stress. So the ultimate stress, so is given here, ultimate right here, 100 kilonewtons. 100 kilonewtons. And the allowable is given to us as the 14 kilonewton load at P. Here. So let's draw a free body diagram. Free body diagram. I could probably do better than that. Straight little curve. Whoa. It's going to be TBD. This is going to be, that's point A, point B, point C. We're going to have reaction forces CY and CX. And then right here, we're going to have force P. And right there, we're going to have theta. Theta equals, let's see, we'd say 40 degrees. 40 degrees. And then right here, this is 30 degrees. So, splitting P up, we're going to have P cosine of 40. And then we're going to have P sine of 40. Splitting TBD up, we're going to have TBD sine of 30 and TBD cosine of 30. And you might be asking why down is sine here and then down is cosine here. When the angle is horizontal, so from here to here, they're measuring this angle from the floor to the angle, then it's going to be sine is up and down. But when it's from the wall to the angle, when it's given this way, we flip sine and cosine. So now cosine's up and down and sine is left and right. Okay, so now what we do is we take, let's see, the moment's about C, because that would get rid of CX and CY. We know P, so we'd be solving for TBD. So the moments about point C are going to be horizontal. So P coming down here. Well, what's the distance from here downward to here? That's going to be 0.8 plus 0.4. 0.8 plus 0.4 is 1.2. So that's our R. 1.2 cross our F, which is P cosine of 40. But we know that P is 14 kilonewtons. So it's 14 times 10 to the negative 2 cosine 40. And that's going to be pushing this counterclockwise, so that's positive, plus, let's see, this is going to be pushing this way, also counterclockwise. Counterclockwise is positive, so now we have sine of 40, so how far is it up, down? So it's going to be 0.6. 0.6 times 14 times 10 to the negative 2 sine of 40. Sine of 40. And because this one, let's see, from here down will be, it's going to be up. Up is going to be clockwise, and then, oh my gosh, this is also wrong. There. This is going over and up. Left, or sorry, right then up. So then right is also going to be going clockwise. So these are going to be minus, so we can say that it equals this. Because they're both minus, we can move them to the other side of the equal sign and consider them both positive. So with this, then, well, how far is this to this? I'm assuming this is supposed to be along point B, so let's just call it point 4. Up and down. Up and down was distance here. Up and down is this distance here, so this is going to be sine. So here we're going to have 0.4 of TBD sine of 30 degrees plus 0.6 TBD cosine of 30 degrees. Now what we could do is we could take this entire expression, take TBD out, it'll multiply back through, and then we're left with 0.6 cosine 30 and 0.4 sine 30. And what we could do now is, since there's an equal sign, we could divide both sides by this. This will equal TBD. Okay, let's put this all in. Alpha y equals 1.2 times 14 e to the negative 2 cosine 40 plus 0.6 times 14 e negative 2 sine 40 over 0.4 sine 30 plus 0.6 cosine 30. And we have TBD equals 0.25387. All right, so now what do we do? So we have TBD. Let's take 100 and divide it by this. Oh, it should be 100 e to the negative third divided by that. No, negative second. Yes. So 100 e, why did I say e? It's times 10. 100 times 10 to the negative second over 0.25387 is equal to 3.93, which is the factor of safety.